Well, hello class. Thank you for tuning in to Professor Choi again today. Today we're going to have a conversation about what is a probability distribution. So this is part of our statistics learning, and today we're going to talk about what exactly is a probability distribution. So a probability distribution is the listing of all the outcomes of an experiment and the associated probabilities with that particular experiment. Now let's conduct a very simple experiment, and I have in my hand a quarter. Now imagine that I toss this quarter and I measure what I get. In this case, I got a head. Alright? Now if I toss it one time, then the probability that I can get a head is basically 50%. Look, I got a tail now. So every time I toss it, if I only do a one-time experiment, then I got a 50-50% probability that it's going to be either a head or a tail because it only has two sides. Now let's conduct a slightly longer experiment. So let's say that we're going to toss a coin twice and we're going to observe the number of heads that you get. So I go toss, record, and then toss and record. Okay? Now this is basically the listing of all the ways in which this can turn out. One way is I toss my coin twice and I get two heads. So the number of heads that I observe is 2. Another way is I get one head and one tail. So I toss it one time and it's a head, and then I toss it another time and it's a tail. Another way is I toss it and I get a tail, and then I toss it and I get a head. And then another way is I toss it and I get two tails. Tail the first time, tail the second time. And those are basically the listing of all the outcomes of this particular experiment of tossing a coin twice. Alright, now, what is the number of heads? Well, I could get either two heads, I could get one head, or no heads at all. And what we have here is what we call the probability distribution. The probability distribution is basically when you take this and you put it into a graph. Now, what is the probability that the number of heads is going to be 0? Well, the probability of number of heads being 0 is one time out of 4 different ways in which this could go. So 1 out of 4, or 0.25, is the probability that the number of heads is going to be 0. Now what's the probability that the number of heads is going to be 1? Well, twice that happens where there is one head out of 4 times, so therefore the probability that the number of heads is going to be 1 is 2 out of 4, or 0.5. 0.5. Now what is the probability that I'm going to get 2 heads? Well, the probability that you're going to get 2 heads is 1 out of 4, because it only happened one time out of 4 possible outcomes in this experiment. And this is what we call a probability distribution. Of course, longer experiments will have more lines and probabilities. Shorter experiments will be smaller, like this. Alright? Now when you have a probability distribution, we can calculate things like a mean, variance, and standard deviation. And if you watch other videos that I've already published, with a mean and a variance, or a mean and a standard deviation, we can start making assumptions about these particular probabilities, especially the amount of people on a probability basis that will land within a certain amount of standard deviations from the mean. Okay? Notice, by the way, that in this particular case we have a normal curve. Alright, so let's get to calculating the mean, the variance, and the standard deviation of a simple probability distribution. Alright, so let's create a problem. Alright, now let's create a simple problem. Imagine that I own a repair shop. So let's say I own a repair shop and I want to know the probability of how many cars I'm going to be servicing on any Monday. So number of cars that show up on any particular Monday. Alright, now in order to be able to find a probability, by the way, remember you have to count the amount of cars for a certain amount of Mondays. So let's say you will take, I don't know, 20 Mondays and then count the amount of cars that come into the shop, and then you will translate that into a probability. So if there were 5 times where there was 1 car, 5 times out of 20, 1 car, then the probability of one car is 0.25. Alright? So number of cars that we observe and probability. 0 cars, 1 car, 2 cars, and 3 cars. And what is the probability associated with that? Well, I did my research and I noticed that 0 cars show up 10% of the time, or 0.10. Then 1 car shows up 0.2, 2 cars show up half the time, or 0.5, and 3 cars show up 20% of the time, or 0.2. Okay? By the way, notice that when you're assigning probabilities, you add up the probability of every event and it has to add up to 1. So all the events have to be inclusive, have to have all the events attached on it, on that probability. Alright? So, imagine that somebody asks you, what is the typical amount of cars that you're going to be receiving on any Monday? What they're really asking you is what is the mean or what is the average amount of cars. Now to calculate the average amount of cars, you can follow this formula. The formula is summation of x p of x. Alright? So, what we're going to do is we're going to do here x p of x. X p of x is just when you take x, which is this number of cars that you saw, and then you multiply it times the probability of each one of those events occurring. So the formula says that I have to do summation x times p of x. So summation of x times the probability of x. Alright? So let's do x times p of x. So I'm going to take 0 multiplied times 0.1, that's going to give me 0. 1 multiplied times 0.2, that's going to give me 0.20. 2 multiplied times 0.5, that's going to give me 1. 3 multiplied times 0.2, that's going to give me 0.6. Alright? Now, the formula says I got to do summation of x p of x, so I'm just going to add that, and I have my answer. And my answer is 1.8. So 1.8 is my mean amount of cars for any Monday. So if somebody asks you, using this example of how many cars you get on a Monday and the probability that they show up on a Monday, somebody says, what is the expected amount of cars on a Monday? You can say 1.8 if you want to be exact, or you could say around 2. That's how many cars you expect on a Monday. Alright, now let's take a look at how do we do the variance and how do we do the standard deviation using the same information. Okay, so the variance says we got to do summation x minus mu squared times p of x. Now the best way to do this is to create this little table. So the first thing that we need on the table is we have to do x minus mu. So every time you're solving these formulas, it's useful to go from the inside of the formula to the outside of the formula. Alright, so you start with the inside stuff and then you move out. So the first thing we're going to do is we're going to do x minus mu. I like to write it down, x minus mu, just so that I know in what step I'm in. Now x's are this and the mu is the 1.8 that we just calculated. So I'm going to do 0 minus 1.8 and I'm going to write it down. That's what x minus mu is. So I do 0 minus 1.8, that gives me negative 1.8. Then I'm going to do 1 minus 1.8, that's going to give me negative 0.8. Then I'm going to do 2 minus 1.8, that's going to give me 0.2. And then I'm going to do 3 minus 1.8, and that's going to give me 1.2. Again, I'm doing x minus mu, which is the first step on my formula to calculate the variance. Alright, now, the next thing it says is I have to do x minus mu and square it. So now, I'm going to take my x minus mu and I'm going to square it. So I'm just going to take these numbers, which are my x minus mu's, and I'm going to square each one of those. So I'm going to do negative 1.8 squared. And that gives me 3.24. Then I'm going to do negative 0.8 squared. That's going to give me 0.64. Then I'm going to do 0.2 squared. And that's going to give me 0.04. And then I'm going to do 1.2 squared. And that's going to give me 1.44. Alright? So again, the formula says x minus mu squared. I did x minus mu, and now I'm doing x minus mu squared. Alright, now the next step on the formula says I got to do x minus mu squared times p of x. So I'm going to do now x minus mu squared times p of x. And all I'm going to do is I'm going to take each one of these and I multiply times the probability of each. So I'm going to take 3.24 multiply times 0.1, which is the probability. Alright, so 3.24 times 0.1. And that gives me 0.324. Then I'm going to take 0.64 and I multiply times 0.2. And that's going to give me 0.128. Then I'm going to take 0.04 and I'm going to multiply times 0.5. And that gives me 0.02. And then I'm going to take 1.44 and I'm going to multiply times 0.2. And I get 0.288. Alright, so if you look at the formula, I've basically done the x minus mu squared times p of x, so I've already done all of this. Alright, now I got to do summation. Summation basically means add. So I'm just going to take this and I'm going to add it. So I'm going to do 0.324 plus 0.128 plus 0.02 plus 0.288. And I have 0.76. Alright? That 0.76 is my solution to the variance. So my variance is equal to 0.76. Alright? So this is my mean and this is my variance for my probability distribution here. Alright. Now one of the numbers that we use in order to figure out the spread of the data is the mean and the standard deviation. The standard deviation is basically just the square root of the variance. Notice that this formula here is basically the same as the variance. What we call the variance is sigma squared, and what we call the standard deviation is just sigma. So basically, in order to find sigma, all I got to do is I got to do the square root of my variance. So all I gotta do is move this over here and do the square root of that in order to get the answer. So I'm just gonna take this 0.76 and I'm gonna find the square root of that. So square root of 0.76, and that gives me 0.8718. And that is my standard deviation. So my standard deviation is 0.8718. Alright, so I hope you like the class today. We just found what is the probability distribution. I explained it, and I show you how to do the mean of a probability distribution, the variance of a probability distribution, and the standard deviation of a probability distribution. Stay tuned for more knowledge of statistics with Professor Choi, and have a good one.